Donc on est très heureux aujourd'hui de faire ce séminaire de l'ATECOPOL, Sémécole, sur les forêts tropicales. Donc on l'a intitulé Forêts tropicales, déconstruire leurs histoires, mythes et futurs, si je ne dis pas de bêtises. Et pour venir parler des forêts tropicales aujourd'hui, du coup on a invité deux chercheurs. Donc d'abord Patrick Roberts qui nous vient de Jena en Allemagne, qui est, si je ne dis pas de bêtises, archéologue à la base et qui est directeur. Alors j'ai noté le titre parce qu'il est assez long. Il est directeur du département de Coévolution de l'occupation des sols et de l'urbanisation à l'Institut Max Planck à Jena en Allemagne. Et il est auteur du livre qui a été paru l'an dernier en France, qui s'appelle Jungle, comment les forêts tropicales ont façonné le monde. Et donc il va nous parler sur une perspective long terme de la coexistence entre les humains et les forêts, et certaines idées reçues et certaines peut-être leçons pour l'avenir. Et avec nous aussi aujourd'hui nous avons Amélie Robert, qui est maître de conférence en géographie à l'université de Picardie, Jules Verne, à Amiens, sur le campus d'Amiens, c'est ça, du coup, qui est spécialisée en biogéographie historique et en géographie du développement durable, et qui nous parlera beaucoup de l'histoire des forêts, notamment au Vietnam, des années 50 à nos jours, plus ou moins, à peu près. Voilà. Un point technique, c'est que ce séminaire, nous avons un invité qui est anglophone, et donc ce séminaire, on va tester un peu de technologie. Il va être traduit en direct, donc Patrick parlera en anglais, ça sera traduit en direct. Et ce thème des forêts tropicales est adossé aussi à un thème qui traverse un peu l'ATECOPOL depuis quelques années, qui est une initiative Art Science qui s'appelle Sans forester, où on met ensemble des chercheurs, chercheuses et des artistes pour avoir une réflexion et une réflexion sensible autour des forêts au sens large. Et cette approche s'est matérialisée depuis quelques années par une performance qui est une balade performée dans divers bois jusqu'à présent, alliant le cirque, la danse et des points de vue situés de chercheurs sur leur objet d'étude et ce que ça leur fait. Voilà, ça c'était pour l'instant un peu plus pub et communauté, on va dire. Et sur ce, on va démarrer. Donc Patrick va commencer. Et Patrick, the floor is yours whenever the machine is ready.
C'est le moment critique.
Okay, thank you so much for coming, and thank you also to Sylvain and Guillaume for inviting me here. It's a real pleasure to be in Toulouse. Thank you also for bearing with me and the machine, listening to me in English. I'll try and talk slowly so that either those of you that understand English can pick it up that way, or the machine hopefully works. So I'm going to talk today about human history in the tropics, or also this could be titled Tropical Forests, and how it's relevant for today. And I've written a lot about this topic because for a long time the tropics have been seen as something of a black box, a blank space on the map of human history, places people didn't want to live or didn't want to go. And our latest research, multidisciplinary research, has been overturning this idea and showing that human societies have lived in the tropics for a long time, and what they did there may provide us with insights into sustainability there today. Is it working? Yeah? Okay, good. So my talk is split into three broad parts. So first I'm going to talk about what does it mean, the tropics. Then I'm going to move on to a broad overview of what we now know about human history in the tropics. And my third and final section is called usable paths, a term I like to use about how we can mobilize archaeology, history, paleoecology to actually contribute to policy and understanding today, with some examples. So the tropics, as you may hear or you may know, can be defined in many different ways. For the purposes of this talk, I'm going to very simply define them as the area between the Tropic of Cancer and the Tropic of Capricorn. You'll also notice in this biogeographic picture that this does broadly align quite significantly to where tropical forests are, quite obviously. There are other environments, of course, within the tropics, savannas, other types of woodland, but really here I'm going to be talking about tropical forests, and so basically all forests that exist within this geographic space. These can be very diverse. They can go all the way from forests that exist in the mountains of New Guinea that get icy in winter, to trees that lose their leaves for part of the year in dry tropical forests. So very different to what the public might typically imagine tropical forests are. I will say that the tropics is a disputed term in history, anthropology, that actually arguably the idea of the tropics even emerged as a result of colonialism, right? So it's worth bearing in mind, but here I'm just using it as a purely descriptive term for this space. And I do this because this space also aligns to really important questions about human Earth system interactions. So the top of this map shows you the density of carbon stored in biological systems. You can see that this is dramatically or overwhelmingly biased towards this space of the tropics, right? Most of the carbon that is caught up in terrestrial ecosystems exists in this latitudinal space. The below map shows you population density. And it's also fair to say that the tropics generally is a place that is home to some of the most rapidly expanding populations. And as a result, basically it's an arena where humans will increasingly be coming into contact with major carbon sinks. And as we know, in the context of our relationship to our planet, this is particularly important. And therefore, understanding human relationships with this is incredibly important to our future as well. This is also shown with these three major statistics that I think are quite also indicative of this. So tropical deforestation is the third biggest source of carbon emissions globally. It's a bigger source of carbon emissions than the entirety of the European Union. So it is massive, right? So deforestation there is having impacts for the carbon cycle on a global scale. The tropics, and particularly tropical forests, are also home to over half of the planet's plant and animal species. What this means is that when we lose habitat, when we lose species in the tropics, it's not just impacting that beautiful biodiversity there, but it's also having an overwhelming impact on the planet's biodiversity because of the biased weighting of biodiversity to the tropics. And finally, tropical forests are also responsible for the recycling of 60% of rainfall, terrestrial rainfall. This means that if you cut down the Amazon, for example, it doesn't just make the Amazon drier, it actually also means that North America, Europe, Africa also become drier because you lose that water out of the entire climate system. So just to show you that basically what happens in these environments is not just of relevance to the people that live in the tropics, but the entire planet, which is why I think understanding human relationships with them is so important. And I've put this image up because, as I sort of mentioned, probably the general public, if I said tropical forest to someone in the street, would think of something like this, right? A rainforest, dense, dark, quite impenetrable to humans in general. And for a long time, actually, in history, in archaeology, it was largely thought that humans didn't want to go into this, that actually the only time we started really influencing these habitats was with industrial deforestation, when we could sort of remove these forests and start doing things within those landscapes. Also in archaeology, they do tend to pose challenges for fieldwork, right? If you think about doing an archaeological excavation in France, usually it involves opening up a nice large trench to dig, and you can do that for many weeks or months even, and get a really good idea about particular sites. But this is a picture taken by my colleague who works in Kalimantan, in Indonesia. And this is what they had to do every day just to get to the site. So if you can imagine this, it's much harder to generally do work in many of these places than it might be in other environmental contexts. It's also very hard to see things on the floor, right? If you're walking through a forest like this, it's very hard to spot archaeological traces. Also, many hazards potentially in the tropics, from all the way to extreme weather events, to disease and things like that. And particularly problematic for archaeologists is that the soils in the tropics tend to be very acidic and very wet. And this is very bad for preserving organic things like bones, other cultural materials that might tell us how people lived in the past. And so for these reasons, as well as this more general cultural perspective we might have about the tropical forests as barriers, it means that archaeologists have often not wanted to go into these settings because they think that it is too difficult and the rewards are likely to be too low. But over the last 20 years in particular, the work of many teams and many multidisciplinary approaches have led to huge changes in our understanding. So this map on the left is a map of the world on a slightly interesting projection, I think, which decenters Europe in particular, and shows you what we now know about dispersals of humans within and out of Africa. I guess it's a little bit hard to see. But what you can see is basically that humans emerging in Africa around about 300,000 to 200,000 years ago were probably using tropical forests as one of the environments that they're evolving into. Then moving into South Asia, Southeast Asia, New Guinea, Australia, we now know that humans are in those tropical rainforests as early as 45,000 years ago. And I'll come on to some of the evidence we have for that later. And then arriving in South America and the Amazon by 14,000 years ago. All this to say that basically tropical forests are a key part of this human story. It's not just savannas, it's not just following coastlines. These environments were key to our early expansions within and beyond Africa. Also, we now know, and I'll also come on to some of this, but generally we now know that things like food production, agriculture, urbanism emerged separately in the tropics. We know that food production had expanded across most of the tropics by 6,000 years ago, perhaps not in the same form of monoculture fields that we think of as agriculture in Europe, but certainly bringing domesticated plants, domesticated animals, and different ways of manipulating and managing environments. Similarly, by 1,000 years ago, we know that there was urbanism in every single tropical continent. And finally, we also know that European colonialism had a major role in then changing land use practices across the tropics. And this is also very hard to see, I apologize. But basically, one way that we've got this information is by applying lots of different techniques. This ranges from putting cores into lakes, looking at sediment cores, to understand how humans interacted with environments through time. That's on the left-hand side. It's doing archaeological investigation in places that previously had not been looked at, combining this with things like, instead of, for example, in France, you might look at charred crop remains to understand what people were eating. In the tropics, this method called phytoliths has been used, which is the silica bits of plants that are left behind and are much more resistant to tropical conditions. There's also remote sensing, LiDAR here, which is the laser survey from the air, which can be used to map through canopies the traces left behind by humans on the floor, which I'll also show later. And it's also looking at and combining environmental history and other approaches to tropical interactions. And what I've been trying to do, and what this diagram is supposed to show, is that we can use all of this information together to try and build understandings of human land use, how humans might have modified these forests through time, and therefore what that meant for the Earth system on the bottom there. Did human changes to these environments lead to biodiversity responses in the past? Did it change the carbon cycle? Did it lead to increased soil erosion? Did it change climate parameters? This is things we can now potentially answer and compare it to our contemporary understanding that I began this talk with. So we can do this through different approaches. I've mentioned some of them. This is stable isotope analysis, which I'll come on to in a minute. We can apply this to hard human teeth, for example, to tissues, to look at what people were eating in the past. We can do LiDAR, as I mentioned. We can even look at living plants in the tropics and see what traces they provide about how humans have interacted with them. So in this case, this is dendrochronology, so cores from living trees. But we can also look at tree genetics, plant genetics. And finally, it's this land use mapping idea, which again I'll show you a bit later, but to try and get spatial understandings of where humans were on tropical landscapes, what they were doing, and what feedbacks that might have had for the Earth system. So now the second part of this talk, as I mentioned, is just giving you a sort of brief overview of how we know what we know about human history in the tropics and how that has changed. Here I'm going to start with my PhD, which was in the island of Sri Lanka, which is an island in the middle of the Indian Ocean. Sri Lanka is very interesting. It's very wet, a lot of rainfall. It's basically very close to the equator. But it also has an interesting patterning of vegetation. So in the bottom left of the island, you have dense lowland rainforest. That brown shape is then more dry intermediate rainforest. And those yellow and pink spaces are more monsoon, semi-seasonal dry forests that actually can lose their leaves through part of the year. And what was really interesting about Sri Lanka was that the earliest human sites found in Sri Lanka by Sri Lankan archaeologists in the 1980s were all located in the rainforest area. At the time, archaeologists on an international level said that can't be the case. You know, we think of humans first getting to Europe 45,000 years ago, humans liking open habitats, or other hypotheses had said humans moved very rapidly around the coast from Africa through Asia and into Australia. So they said, well, maybe things are wrong. Maybe the rainforest wasn't there in the past. Maybe it changed with climate change. Or maybe these humans moved around the island, and so actually they were briefly staying in rainforest, but living off resources around the island. And this is where we applied isotope analysis to human teeth and also animal teeth. This is tooth enamel. And the nice thing about tooth enamel is it preserves in even the harshest of conditions. People have used isotope analysis of tooth enamel to look at hominin diets, so that's our human ancestors, back to 8 million years ago. Right? So it's a very resistant material and allows us to get around some of these issues of organic preservation. And isotope analysis, I won't go into too much detail, but it basically looks at how different distributions of isotopes of different elements are linked to different biological, ecological, climatic processes. So particularly in the case of carbon isotopes, so this is relating carbon-13 to the normal carbon-12 isotope. The distribution or relative abundance of these isotopes in different biological materials tells us something about different processes. On land, one of the main processes is this difference between C3 and C4 plants, which you may or may not have heard of. This basically just refers to different photosynthesis practices. And it's important because it distinguishes crops like wheat, potatoes, rice, to crops like maize, because maize is a tropical grass. And you can see in the bottom, this leads to different values that we can distinguish and we can measure. Importantly, these plants also have environmental distributions. So in the tropics, tropical forests are dominated by C3 plants, so they have these lower, more negative values, whereas in tropical grasslands, C4 plants dominate with higher values. So this means that we can measure the isotopes of an animal, of a human, and work out how much of these different environments they're relying on, they're using, they're eating from. There's a further system on the right-hand side of this diagram that says even within tropical forest or even within C3 plants, the impact of shade in forests, of recycling carbon dioxide gases, also leads to even lower values. So even within C3 plants, dense dark forests have distinctive values again. And so for my PhD, I applied this to Sri Lankan animals and the human remains that we had from some of these early cave sites. This graph is just showing you the animals. So you can see on the left-hand side, as predicted, those animals that live in wet zone rainforest have low carbon isotope values, which is on the bottom here. Then those in the orange space, this orange ellipse, are living in these more dry intermediate rainforests. And those animals in the right-hand side are those living in savannas and grasslands. So you can see that it's working for the animals in Sri Lanka, right? It's meeting our expectations. So to this, we can then add the humans. So this is the earliest human we have from 36,000 years ago. And you can see that it basically places within this lowland rainforest environment. So it tells us that this human was largely relying on rainforest resources. What's even more interesting is that the animals found with this human span all the way from rainforest conditions to more open habitats. So not only could humans rely on rainforest resources, they were choosing to, right? There was clearly some grassland animals here that if humans did always want to go to the savanna, they could have done, but they didn't. So they had developed a specialized adaptation to rainforest. 20,000 years ago is the last glacial maximum. In Europe, this made things get very cold. In the tropics, it tended to make things get very dry. And so what happened would forests would open up a bit, they would retreat, and we see that in the animals and humans. We see more animals from a site which is in, today, the wet zone rainforest, now moving to this dry intermediate forest. And all the humans are placed there too. But even now, there's no humans in savanna grassland space. And this continues through the terminal Pleistocene, Holocene. And the sort of exception that proves the rule is the humans that appear in this space 3,000 years ago. And they appear there because they are appearing at a time when millet agriculture made it into this part of Sri Lanka. And millet is a C4 crop. So again, the only time that humans start looking C4 in this part of Sri Lanka is when agriculture arrives and a C4 crop. And even then, there are still humans relying on forest. And so what this work showed is that really humans not only could, but often chose to live in tropical rainforests, even as we were expanding into different parts of the world. And this went against sort of the dominant view at the time, and also obviously proved the Sri Lankan archaeologists correct that had been arguing this since they found these fossils. And at the time I thought, well, you know, there's no reason, therefore, why our species was not doing this from its earliest evolution in Africa. And lo and behold, this year, in fact, a month ago, 2 months ago, we now found evidence for humans living in rainforests in Africa 150,000 years ago. Again, this changes ideas that we emerged purely in savanna habitats or purely in coastal settings like those of South Africa. Actually, what I would argue makes our species unique is our habitation of all of these environments from the very beginning of our arrival on the planet. And I would argue that tropical forests have played a major role in showing us this. We also now know, so from that point I was interested in, well, if we got that wrong about our earliest evolution, our earliest dispersal, what else did we get wrong about human history in the tropics? And you know, traditionally ideas of agriculture had been thought to be impossible in the tropics, right? Ideas of poor soils, dense forests. It was really thought that this would not be a place where you would look for the origins of agriculture. But a lot of work, particularly in New Guinea, for example, has shown that actually it's the tropical forests in New Guinea are home to some of the earliest examples of humans cultivating plants. Bananas, early ancestors of the sugarcane, yams and taro, underground storage organ plants. And doing so by cutting ditches to drain landscapes, planting bananas in forest patches next to more drain landscapes where they were growing sugarcane. So really changing whole landscapes to harness these different crops and cultivating them. Not quite as early as things are happening in the Near East, but not that far away. The tropics are also home to some of the most important crops and some of the most important animals to our diets today. I haven't put that on the slide, but maize is a tropical grass, as I mentioned earlier. It's one of the most important staple crops around the planet. It was domesticated in and around tropical forests in Mexico. Oil palm is now obviously problematic in many senses, but it's more of how it's being grown, how it's replacing rainforest today. When it was first domesticated, it was grown in agroforestry systems within rainforest, back in West Africa about 5,000 years ago. The chicken is the most frequent animal around the planet today, more frequent than us. We have turned it into a major part of the biosphere. In fact, it's even been argued to be a marker of the Anthropocene. The chicken was domesticated in tropical forests from its ancestor, the red jungle fowl, or the hybridization between the red jungle fowl and the gray jungle fowl, somewhere between South Asia and Southeast Asia. The water buffalo is also incredibly important for people's diets across Asia. People use it for traction to help them manage their fields, but also buffalo milk is incredibly important to many large and often growing Asian populations. It too was domesticated in and around tropical forests. So just to say that far from being sort of against or hostile to food production, many of the things we take for granted today when we go shopping in a supermarket come from tropical forests. Moving now to urbanism. Again, urbanism was seen as something also potentially impossible or that tropical forests were hostile to cities in the past. Anyone who's seen that film, The Lost City of Zed, obviously the people involved in that were pretty nasty colonizers. They were sort of romanticized in that film. But the principles they present in that film about this idea of how unlikely people thought it was that there would be cities in the Amazon is real. This is what people believed. And even then, when indisputable evidence, like in the classic Maya region of Mesoamerica, was found, as you might have read from Jared Diamond's Collapse book, for example, it was thought they were doomed to collapse. Basically, that even where we have cities in the tropics, they were doomed to fail. And part of this is because when we do go to these sites today, in many cases they're overgrown, they look like they have sort of failed. Or they're just isolated patches of ruins. And this is where LiDAR comes in, which I mentioned earlier. This is this laser scanning from the air that can look through the canopy to see what's below. And using this method, we can go from something like this. This is Angkor Thom, if anyone has been to Cambodia. This is kind of one of the main temples that you would visit as a tourist. You'd go there and see, wow, what an amazing temple, but oh, look how much the forest is reclaimed. Or you know, human impact compared to forest is very small. This is what LiDAR shows us under this. It's not just a temple, it's a whole giant landscape of urbanization. In fact, I don't know if I have it, I do have it. On this slide, mapping using LiDAR, using survey, including by a French team in Paris, the EFEO, played a huge role in mapping this city, which is now an area called Greater Angkor, and has now been documented at a size of 1,000 kilometers squared. That makes it the biggest pre-industrial city by area. Bigger than Rome, bigger than Constantinople, bigger than these ancient Chinese cities, and actually bigger than most metropolitan areas of many large cities today. And so, as I mentioned, this was done by Poitiers at Paris Institute, but also my good colleague Damien Evans, who sadly passed away a few years ago. But he really revolutionized and applied this LiDAR approach to these archaeological questions, and he's responsible for this kind of picture of Angkor we now have. This has also been found in other places. It's not just Angkor. It's been done in Sri Lanka, which is where I've worked a lot. And here, survey methodologies and now LiDAR is being applied, is showing vast networks and management of waterways connected to these cities, showing just how extensive these landscapes were, of people modifying water channels to have access for rice farming, for fresh drinking water. And so I suppose one question then is, well, if we have all this evidence, then why for so long have we thought that there was no one in the tropics? And one reason for this are the impacts of European colonialism from this point. One is the fact, this is quite well known now, is that European colonizers didn't just bring themselves, they often brought diseases that indigenous populations didn't have immunity to. So for example, in the Americas, we now know that within about 100, 150 years of Europeans arriving, 90% of the indigenous population had died from diseases. Now, if we think about what COVID did and how it disrupted our societies, that had a mortality rate of, I think, 1%. This is 90%. It is by far the worst public health disaster on record, and had major consequences for the indigenous people living there, as well as their forms of urbanism, forms of land management that I've just mentioned. Also, Europeans tended to replace what was there with different forms of agriculture, right? More things like monoculture, plantations. This is a sugar plantation, but also maize plantations. Also, even within forests. So, for example, the British in India tended to plant specific trees that they could then go and log. They looked like forests, but they were plantation forests of single species. Europeans also brought with them their own new ideas of urbanism, so very compact forms of urbanism that were similar to what existed in Europe. Also made it easier to control indigenous populations. You could tax them more easily, you could get labor more easily by having them all in one place. And also more extractive approaches to landscape, right? The Spanish famously undertaking mining of gold and silver in the Americas as well. So really just new approaches to these landscapes that have served to both mask and also eradicate indigenous, in some cases, approaches to landscapes. And we can study this through these different methods that I've mentioned. So one, this is the dendrochronology again. So some of you might have come across this. This basically uses the ideas of tree growth rings. It's traditionally been used in Europe to say if I dated a beam from this building, I could date the wood and tell you how old the building is. Where you can actually also use it in living trees to not just look at dating, but also to look at growth patterns. So you can sort of see from these diagrams where the rings have a big spacing, that means the tree grew a lot. It did very well in those years. Where those spacings are much smaller, it didn't do very well. The growth was much more stunted. And so if you get a whole record together like this, you can start to understand, when were forests growing out? When were they contracting? When was tree growth being promoted? When was it being limited? And we can then compare that to climate records to see, does that link to climate activity? For example, trees doing well when it's wet, maybe. Or does it also link to what we know about archaeology and history? And then we can see, did human management of these trees shape these processes? And so one of my PhD students was applying this to Brazil nuts. You might know this tree. This is these big nuts that many people eat today. It's also one of the largest exports from the Amazon, is Brazil nuts. And if you go through the Amazon and you come across villages, you'll almost always find Brazil nut trees. And this is because they've been managed by indigenous people for thousands of years. They're found at archaeological sites, the earliest archaeological sites in the Amazon 13,000 years ago. And they've also been managed in different ways through time. You're not going to be able to see this again, I suspect. But basically what he did is he took tree cores from living Brazil nut trees in the area of Manaus. This is one of the major cities in the Amazon region of Brazil, Amazonas region. And he looked at how the growth had changed through time. And indigenous people promote the growth of Brazil nuts by planting seeds, but also by practicing fire and clearing landscapes slightly, because Brazil nut likes light. It actually doesn't like very dark, dense canopies. And so indigenous people, where they want to promote Brazil nut, will periodically, every now and again, clear parts of the forest so that it can grow really nicely. And so what he found is the trees grow back 1,000 years as well, so we can get a record back 1,000 years. And prior to European colonization, we can see these periodic periods when humans are burning or clearing parts of the landscape to promote Brazil nut growth. Then, when Europeans arrive and move indigenous people away from Manaus, we see the trees start to grow really badly because there's no one managing them anymore. They're sort of being left to closed rainforest. And so even within these living trees, we can witness this process of human history changing and of changes on the landscape. Another approach we can use is to look at these lake cores, as I mentioned earlier. This is like the trees, but actually this time getting cores out of sediment in lakes, because these lakes catch what's happening in the environment. They catch pollen from trees and plants, they catch charcoal from fire, and we can see how this has then changed through time and how humans or climate might have shaped these environments. And so going back to the impacts of disease then, one of the most famous hypotheses about early Anthropocene impacts is that the impact of disease by wiping out 90% of the indigenous population was so significant that basically by removing people from the landscape, it led to forests regrowing. As they regrew, they sucked carbon out of the atmosphere, something that is arguably, or been argued to be visible in the Antarctic ice core, and that this change was enough to have set off the coldest period of the Little Ice Age that was also felt in Europe, right? For example, in the Netherlands, people were skating on lakes that had never frozen over before. Now, the mortality is not really in question. Historically, archaeologically, we do know that this 90%, 80% mortality is true. The impacts on the forest, though, are a bit more questionable because we know, as I've sort of already hinted at, indigenous people in forests didn't clear forests like Europeans do. They would grow, say, maize, they would grow things like cassava, manioc in small patches. They would leave, the forest would regrow, they'd go somewhere else and do it again. They'd also practice agroforestry. Meanwhile, when Europeans arrived, they tended not to leave forest alone, but rather to cut it down. So actually, this hypothesis is potentially problematic in terms of what we now know. And so what we did is we collected all the available cores from South America, Central America, North America, but also the Spanish Pacific, so the Philippines, Pacific Islands, to try and see, do we see forest regrowth after this, what's been called the Great Dying? And what we can see is, again, it's going to be hard to see, I'm sorry, but basically what we see is in some cases, there is a change. In other cases, not. In other cases, the forest actually gets more open because of colonial policies. So interactions with the forest are far more complicated. And we also see this in the Philippines. So this is one area that has perhaps been, at least relative to the Americas in this regard, been somewhat neglected, at least in the international literature. But this was the place where that really the Spanish started trying to put in place a kind of global trading framework linking Mexico to the Philippines to markets in China and Southeast Asia, and then back to Europe. And there's therefore an interesting place to explore the degree to which these global trading systems, these new responses to urbanism, for example, impacted landscapes, impacted environments. We know, for example, at Manila, the Spanish really wanted to try and build a kind of European-like city in parts of Manila, which was this kind of walled, what they called intramuros, this kind of walled city. But within this walled city, there was probably maximum 400 Spaniards living at one point in time, whereas outside the walls, you had Chinese traders, you had indigenous Filipino communities practicing different forms of urbanism at the same time. And this is one of my favorite images, just to sort of show you why this is relevant or how things link. This is a Starbucks next to the oldest building currently standing in Manila, which is just behind the Starbucks, which is an old church. So just to show you how these histories of colonialism, which was then brought by the Americans to the Philippines, are also found together in some of these cities and shaping how people experience them today. So we've used different methods in the Philippines to try and look at the impacts. On the left-hand side, we tried to review what plants, what animals were brought to the Philippines by the Spanish, Goat was probably already there through Islamic trading networks, but certainly increased ranching with cattle, with horses, would likely have had impacts on Philippine environments. Also bringing new forms of new crops, like cacao is in that top right image. And then what we've also done is used historical archives to try and quantify changes in environments. So this is actually from American imperialism in the Philippines. And what it shows is the top left is showing the hectares planted of different crops. So things like coffee, chocolate, tobacco, coconut trees, and maize and sugarcane. And on the right-hand side, you can see agricultural production. And the Americans argued, they made a big point of saying that part of the reason for colonizing the Philippines was so that they could make things more efficient, so that they could bring better, more productive forms of agriculture. As many European colonial systems have tried to argue that they're bringing benefits to local communities. And what is important here is to look at the bottom two graphs, which show the actual yield, so how much crop you're getting out per unit area. And you'll see that actually this doesn't really change. And so the Americans were only increasing agricultural productivity by expanding the area under production, not actually through more efficient methods, and would have ultimately therefore had environmental impacts. They would have cleared more forests, which would have had then more impacts on the environment. So even what they said they were doing, even in their own records, they're not actually doing. They're not increasing efficiency. It's kind of this myth of colonial improvement. And one thing we've been trying to do, so to get back to those Earth system impacts that I started this talk with, as archaeologists, we're very good at going down, right? Very good at opening a site and digging down, but we're less good at this spatial perspective. But to actually start to look at Earth system relationships, we need to sort of be able to look at what people were doing, looking at land use change on a wider scale. Earth system scientists have been interested in trying to do this for the past so they can make better predictions for the future. So two examples are up here. The bottom one is a Hyde 3.2 model. This was done based on a relationship between population density and land use estimated for 20th century Europe. You can see what this does for the tropics. This is the tropics at 1750 AD, and you can see that that model basically suggests that no one was in the tropics, which is completely wrong. The model above it is based on some kind of very rough estimate between population and land use for pre-industrial Europe. It does a little bit better, so it's able to show land use in places like Mexico, where there are things like maize fields with the classic Maya, which start to approach things that we might think of as agriculture from a European perspective. It picks up India, it picks up Southeast Asia, but it completely ignores all the people we know that were living in the Amazon, all of the people in Africa that had vast empires, all of Southeast Asia and New Guinea. It's still not showing anything. And so one thing that we've been trying to do in my research unit is to bring the evidence from archaeology, from history, from paleoecology to build better maps of this, basically, better understandings of land use that can advance on these. Because if we can do that, then we can start to see how different practices, different forms of urbanism, different forms of food production might have interacted with things like precipitation, the carbon cycle, and temperature, which can then perhaps provide us with alternatives or alternative pathways when we think about our relationships to these environments today. So I just want to conclude then, that's a more broader perspective on how the past can be brought to bear on today. But I just want to finish with a couple of case studies to show some concrete examples that I think show where this understanding of human history is really important. Because I think as archaeologists, it's become a buzzword that we are relevant to the present, right? A lot of us do this for funding agencies, to fight against cuts to science. But I want to show you that actually it is true, right? With some specific examples here. So this is going back to Sri Lanka. You might remember that these ancient cities in Sri Lanka, dating to about 3,000 to 1,000 years ago, they're located in this dry zone of the island, and they built vast water networks to allow them to survive through droughts. For From 1,000 years ago, these cities basically started to fade. The populations fragmented. And the population, this urbanism moved further south. So when the Portuguese, the Dutch, and the British colonized Sri Lanka, most of the habitation was in the south area. And these water systems were sort of left abandoned. Now there is, though, actually a city that exists in Anuradhapura, which was the first and longest running capital. And what the population now does for water is that they dig wells. And this was sort of in part stimulated by the British when they created a town there. One problem with these wells, though, is that actually it's leading to masses of kidney disease because the groundwater is contaminated either with trace metals or certain microbes that there's a lot of research being done on. And so what's interesting is when we now go back to research these water systems, which actually are based on running water, they're based on storing rainwater, making sure it flows and stays clean, that the irrigation department, the medical department, are now interested in rehabilitating these ancient structures because it might provide a more healthy form of water security than the well systems. So just to show you that even today now policymakers are looking at these systems and thinking, maybe we can actually use these, learn from these as well. Another more broad perspective is cities like Greater Angkor had this large-scale footprint, and it looks like they were combining agriculture and forests within the urban area. So when we think of urbanism in Europe, we tend to think of this very dense city with a wall, and then the fields outside somewhere, right, the hinterland. And that's what we think of as urbanism often. But these tropical forms of urbanism in the past seem to have combined field systems, the forest, woodland, orchards, managed areas with temples, houses, all interspaced within this kind of what's been called a low-density agrarian urban network. And what's interesting is that, again, urban planners today are starting to try and factor in green areas back into tropical cities because trees often stop soil erosion. They often limit the impacts of mudslides. And actually also, if you could move field systems back into within urban areas, your food security is boosted as well, right? Because you can get your food from the immediate area. So this is also something that's being looked at with examples from the past being drawn upon. Also, I showed Manila in terms of how pathways of colonialism can lead to how cities are being built in different ways, how they're organized. This is work by a postdoc called Fred Stokes. He's an environmental historian. And so what he's done is mapped Guarani resistance in the Atlantic rainforest of Brazil. And what he's been able to show is that there were early Portuguese slave raids from the coast inland to try and capture these communities. And where these indigenous groups managed to stop those raids or resist them with warfare is also where forest is still standing today. And because what happened is actually where those slave raids were successful is ultimately where railways were built. And railways tend to also stimulate deforestation. They provide access to extractive frontiers. And so you can very much see this pathway of colonialism, of extractivism, and how historical processes have shaped where that has proceeded and where it's also been halted in different ways. And finally, I think this is perhaps the most evocative example. This is the wet tropics rainforest UNESCO area of northeastern Australia. Some of you may have heard of that. You're more likely to have heard of the kind of its partner in this UNESCO heritage, which is the Great Barrier Reef, which is just off the shore. And in the 1980s, UNESCO decided to make this a site of natural heritage on the basis that these forests were home to species that were sort of preserved since Gondwanaland. So millions and millions of years old, these species were being housed within these forests. So they made a nature reserve, and they stopped any form of human activity within this nature reserve, right? They wanted to protect these plant species. What they didn't take into account was this millennia of evidence for Aboriginal communities living in these environments and managing them. So on the left, you have what they called a pocket. So they would use fire to open up areas for settlement. They would use fire to open up pathways to move between settlements. And they would use fire to even manage and shape these forests, which I'll come on to in a second. And although this had been discounted by ecologists, actually we now know or think, based on archaeology, history, ethnography, that there were many more Aboriginal people in these places prior to British colonialism than was then documented afterwards, because in many cases the British either murdered them or moved them to different places. Although not all. Some people, of course, remained and resisted as well. And so what happened is, so in panel A, what you can see is the forest being managed by these Aboriginal communities. So what they're doing is frequent low-level burning. This is maintaining areas for settlement. What you'll also notice it's doing, it's also maintaining a cleared understory. So they would do this because it would boost populations of large birds, cassowaries, and also wallabies that they would then hunt. What this fire also did is it promoted these trees that you can hopefully see, well, it's a bit hard to see, but have this white trunk. So these trees are trees that are very fire resistant. So if you apply fire to a landscape, these trees do very well. And these trees would form on the edges of rainforest when you're applying fire, or they'd form on the edge of settlement. Sometimes they also provided fruits, so they could be very important for ecosystems. Now, what happened in panel B? This was when humans were kicked out of the reserve in the 1980s. No more fire, no fire allowed. And you can see that the rainforest starts to grow. Now, to us as Europeans, that sounds great, right? Initially, great. It's working. It's letting rainforest grow back. Fantastic. Rainforest area is expanding. What these rainforest trees are also doing, they're now out-competing the fire-resistant trees. You'll see those white trees start to look very swamped by rainforest. And panel C is what happened in the last couple of years. Climate change, drying, and now you have fire everywhere. You have it, basically you've got kindling tinder boxes on the floor because the understory has not been cleared. You've no longer got these barriers of fire-resistant trees, so it's just sweeping through these rainforests. And so what actually happened is that fire has now even destroyed the natural heritage that people thought they were trying to protect because they forgot about the cultural heritage. And so just to show that if archaeology, if history, if ethnography had been included in that designation from the beginning and acknowledged that fire was a really important part of this ecosystem, there would have been a more productive outcome for sustainability. So just to show really a concrete example of where understanding the past and history is really important. And so to there, I just want to finish. I want to thank my colleagues at the Institute and on the projects we're working on, as well as the funding agencies. And I think also being passed around is this book. If you're interested in reading more, there is also a French version, which I didn't write, but was translated apparently quite well. So that's also available if anyone's interested in reading about these things a bit more. So thank you for listening.